We learned that elasticity is the property of a matter due to which any object tries to regain its original size and shape after the removal of any external force that is acting on it. In case of this rubber, if I apply force on it, the length of the rubber increases. But when we stop applying the force, that is when we remove the force, it will regain its shape. So, we know to change the shape of any object, a force is required. So, by applying force, I change the length, and when I remove my force, it regains its shape. So, the change of the shape takes place. So, behind the change of this shape, a force is required. So, to change the shape of this rubber, a force is required. So, the force is generated inside it. That force is responsible for the regain of its shape. So, that force is called the internal force of it. That is, when I apply a force on it, a internal force is generated inside it. So, the internal force that acts per unit area of any matter is defined as stress. Clear? The internal force per unit area is defined as the stress of that body. So, we can define as stress equals to internal force area of cross section, internal force if area of cross section A. So, stress equals to internal force which is generated inside that matter by the area of the cross section of that matter. And now, if by applying force I change the length of it by 10 centimeter, so to regain its original shape, it must have to compress by 10 centimeter. That is, if 10 Newton force is required to change the length by 10 centimeter, same amount of force is required to regain its original shape, that is 10 Newton. Cleared? If this is the length, that is 3 centimeter, and by applying force of 10 Newton, if I change the length of it by 2 centimeter, then another 10 Newton force required to regain its original shape. Otherwise, if it happens that the external force is 2 Newton and the internal force which is generated inside it is 5 Newton, then it's not possible to regain its original shape completely. From this, we can say that the internal force is always equal to the external force only when the object regain its original size and shape completely, not partially. Clear? So, we can write that internal force equals to the applied force by area. This is F, this is A. Next, unit and dimension of stress. So, we learned stress equals to F by A. So, units in SI system, in CGS system. So, unit of force in SI is Newton and area is meter square. So, in SI you can write the unit of stress is Newton per meter square, and in CGS it is Dyne per semi square. These are the units and dimension of stress equals to dimension of force by dimension of area. So, dimension of force mLt minus 2, dimension of area L square, so mL minus 1 T minus 2. So, this is the dimension of stress. Unit in SI Newton per meter square, in CGS Dyne per semi square, and dimension of stress mL minus 1 T minus